Good evening, everybody. Sorry, yesterday I was not able to take the class, so I had to postpone it for today. Okay, so Chinmay, Praniti is not coming. Milan,
I don't know, sir.
I
She
think
told she
many.
would attend today.
Milan, I
I'll
think
ask
many
her.
are okay.
Hello,
Milan,
sir. Yes, sir.
yeah, many are. I think Shruti is not there. Priyanka is not there.
Yes, sir. There are
Then
some. Actually, I messaged everyone, but they are not responding.
okay,
Actually, they are not replying me.
okay, no
Excuse
problem.
me, sir.
Yes,
Sir,
yes,
Rajapriya
Gayatri.
won't be able to attend.
Okay,
Okay.
okay, fine. Any doubts in the codes of the last class? Last means last week the I had given the codes. Any doubts in that? Okay, nobody.
No, sir.
Okay. Okay, let us start with the next topic, that is machine learning directly. So please set the working directory. Okay, take this course. Please use this dev tools, development tools. Otherwise, this will not install. So first, try to install this tissue gene expression, the library. If you have any doubts, let me know. If it is not installing, let me know. My screen is shared. Yes. Please, everybody, try to use these 4 codes for this.
Sir, Pranati won't be able to attend today. Sorry, she has exam tomorrow and she's out for work.
Okay, fine. Okay. So all are able to do this?
Sir, but the library tissue gene expression is not installed. It says error in library.
This library DevTools is installed?
Yes, sir.
This one. If this is installed, then first you give these two commands, library, then install this. Then it will happen.
For library,
Because
DevTools, it
initially
says loading required package, use this.
Okay, yeah. Do not give this command before. It will not take. First you to give these two commands, number 1 and number 2, then it will take.
Yes.
Yeah, it will happen.
Yes, sir, it's done.
Yeah. Initially I gave only these two commands. Using these two commands you cannot install it.
Yes, sir, it's working right now.
Okay. Others? Chinmay? Divya?
Yes, sir, it's installing.
Okay.
Yeah.
Chinmay? Geeta?
Yes, sir, I got it.
Okay. Milan, Prabhu?
Yes, sir, done.
Okay, Rajapriya, Saidivya, Shravani.
Yes,
Sir,
sir.
it says
Okay.
installed underscore GitHub is not found.
This did you install this library DevTools?
Yes, sir.
Then this will work.
I'll try it once again.
Yeah, last day also I think we did this. Last class I think we did this. The last week code we had this using DevTools. We installed it. Dynamic class.
Yes, sir. Now it's ready.
Yeah. So everybody got this? Any doubts? Anybody who could not do it? These 4 commands? Yes or no? Anybody for whom it is still not installed? Let me know. Okay. Then what you are doing is we are computing the distance between each samples. This is the distance. This will take some time. Once this D is done, then do this library rafalib. If the library rafalib is, I think it is actually under the DevTools, so it will not give any error. If it is not there, then you have to install with the install packages. I think it should work for you all. In this code I gave you, yes. You have to wait for some time till this. You see here, this one red color sign is there, means it is still running. Once this is stopped, you will see the symbol here, the greater than symbol. So till that time you have to wait. Chinmay, did you load this one, the datas I had given in the last class in your Excel, and are you able to read it using your R?
Yes, sir.
Okay, others, Milan, could you do it? The data set which I had given in the WhatsApp group. Milan, Divya,
Yes, sir.
okay. Haripriya,
Yes, I was able to install it.
okay.
Sorry.
Prabhu, Prabhu,
Yes, sir. I've installed it, sir.
okay, good. Yeah, this is done for me. So I can go ahead with this library command. Yeah, if it is taken means there is no supporting things, it has taken it. Okay, so it is, we are calling for the cluster function. So it has clustered it, and see it is cluster method is complete. Distance elucidation and number of objects it is taken is 189. This is the clustering. So we'll go ahead with the clustering. You need to give the plot for the cluster dendrogram. This is the command for the plot. So everybody, I think you are seeing this dendrogram. Dendrogram, this is actually the phylogenetic tree. I think everybody is seeing it in your R. Got everybody this one?
Yes, sir.
Okay, great. So let us go on. Let us cluster it with the labels. Labels in the sense with the distinct colors. We are giving the color, that is you are actually classifying it. You can see separate colors have come based on the different various classifications. So you can actually download this image and you can check it out, which is the other organisms and which are all coming in the same cluster. So this is the clustering I was talking in the last class. Okay, I think everybody got it.
Got it, sir.
Okay. So we have defined a particular distance here. Okay, say for example, here we are given h equal to 120. A specific distance is given. I think in your phylogenetic tree, you remember it is one is distance tree, other is non-distance one, that is the cladogram. Now you are specifying a particular distance. So from this 180 part, you can measure the distance of all. You can remember the phylogeny in the similar manner you are doing it. In phylogeny, you have rooted tree as well as non-rooted tree, in which you have no specific roots defined. Here, we are defining the root like by drawing a line so that you can calculate the distance of the individual sample from the particular distance. So it is given as h equal to 120. So h equal to 120 is here. Got it, everybody?
Yeah, sir.
So now you can see the clusters, how it is formed. Sorry. So you can see the clusters. So cerebellum, colon, endometrium, hypothalamus, kidney, liver and placenta. And the clusters, how it is formed. So we have cut the particular tree at k equal to 8 and we are seeing the distance individually. So next you can move it with the k-means function for the clustering. So k-means function we have seen in the, that is for the k-means for creating the individual clusters. So here in the first plot you have colors to represent the actual tissues. In the second it is represented as clusters. You can check it out. In the first there is no clusterization, there is no cluster in the first plot, whereas in the second plot there are, you can see it is all in the cluster. The tissues are actually represented with the in the clusters. You can check it out. You can see how the clusters have come based on the different colors. Got it, everybody? The clusters?
Yes, sir.
Okay. Next, you can take the table of the individual clusters, how it has come. Further, let us move on and draw one MDL plot. So you're having the MDL plot using this one in the clusters with, you can see with the clusters and how the in the tissues are there together. Okay, again you're making the table. Done, everybody? Next we will go with the heat maps. So what is heat map? Somebody please Google it and see, check it out. What is heat map? Chinmay?
Yes, sir.
Yeah, just put this heat map in Google and read it out what it is and how we can make the clusters using the heat map.
It is to visualize hierarchical clustering.
Yes. Yeah, Chinmay, you can just share the screen for the Google definition. I will enable the share.
So
Can
I
you-
told
Yeah,
Jovita.
it's okay. It's okay.
Should I
Chinmay?
share?
Okay, you can share,
No,
Jovita.
sir, no, it's okay. No, it's okay.
Okay. Where is Chinmay?
Yes, sir.
Yeah, you can share. Just the definition part. Definition with the picture.
Sir, is it visible, sir?
Yes. Okay, you have made the Google also in a black color. Okay. Okay, so here the cluster individual grouping, it is made with the colors here. So similar colors and how it will be the colors will be, light colors will be formed. It is how the clusters is coming to, in a different separately. Yes, that is also fine. Yes, this color usually this is the widely used for the heat maps. You can see here everywhere it is phylogenetic tree. Yes. All are whichever is in the same group, they are all given in the similar colors. I won't say same colors, it is similar colors. So green, whichever are in the same what you call similar clusters, they are all given in the green. Then in the black, whichever in the black ranges, whichever are in the red ranges, they are all similar. Same means exactly which is same the color, that is all say same what you call, maybe the same tissue, maybe the same organism. Otherwise, if as it is a phylogenetic tree, similar it is always detected. So that is for the definition in the biological part. Whereas Chinmay, whatever he has told, he has told general heat map definition. Even Jovita, what she has told, it is a general heat map definition. For our part, since we are using with the biological data, we have to tell in relation with the phylogenetic tree, because we are studying phylogenetic tree in our bioinformatics. So you can relate our bioinformatics here using the heat map. So in the bioinformatics, we have phylogeny, how the same or related organisms are classified together. It is the same definition which is applied here for our heat maps. Okay. Okay. Yeah, Chinmay, you can unshare your screen.
Yes, sir.
So I have already, I think, given the code. So check it out if this library R color viewer is working. If it doesn't work, you have to install it again. So check it out if this library function also works. Usually all are a part of this dev tool, so it will work. Then you have to install this gplot. Gplot, you have to install it. How? I think everybody knows, using the install package function. Using the install package function, you have to install this gplot. Finally, this is the heat map code. So gplot, everybody installed it. I think everybody knows how to install the gplot. So everybody got this heat map. So if you are given a particular set of organisms, you can use this heat map function and you can plot the heat map or generate the phylogeny. Everybody got this heat map, and everybody knows how you can how you can predict phylogeny using heat map. I guess everybody knows it. Anybody who cannot understand this, they can unmute and speak. Anybody who doesn't know phylogeny, please let me know. Or you could know, or who could not understand this heat map. Got? Anybody who still are doing it? Shall we move ahead? Is it done for everybody? Why you all are silent? Divya, you got the heat map?
Yes, sir.
Gayatri, Chinmay?
Got it, sir.
Got it, sir.
Okay. Geeta, Haripriya,
Got it, sir.
Jovita, Milan,
Yes, sir.
Prabhu, Priyanka, Rajapriya.
Yes, sir.
Okay. Sai Divya, Shravani.
Yes, sir. Got it, sir.
Okay. Fine.
Yes, sir. Got it, sir.
Okay. So now we will move with the principal component analysis. So everybody try to check the data set. Initially we are given tissue gene expression. If it is still there, you can use a separate R script and go ahead. So check out your data, tissue gene expression, and check out the dimension. Then prepare the table for the tissue. So just take the kidney sample and try to find out the distance between them. So you're defining the values x, y, and z. So now you can calculate the distance and find out its class. This is a similar function you used initially. Here you have to use for the getting the component, principal component. Okay. So class D matrix. Okay. So you got the distance between the genes. Now let us make the plot. This library should work for you all. This is just a standard plot. Got it, everybody, this plot?
Yes, sir.
Okay. My part will be error here because you have not given any value within it. Let us go it with the MA plot. One with the MA plot as well as the scatter plot. The left one is your scatter plot and the right one is your MA plot. So still now we have not come with the principal component, but these are all the just the dimensional plots. So this particular plot is a SD preserving property plot here. So here the SD, that is the deviations are preserved here. So this is the rotation plot that you have changed the data and you have plotted it again. Here we will go ahead with the principal components. So this is, you are defining the data for your principal component, PC1 and PC2. Okay. Yeah. So applying your tissue data. Here you have used the SVD command to return the three matrix in the three dimension. So SVD is your single value decomposition. So let us plot this. This is your gene expression data. So here you are plotting the graph for the percent variability. So percent variation is explained by each principal component of the gene expression data. So let us finally do the cumulative frequency of the principal components of the gene expression data. Okay, got everybody? Everybody got this?
Yes.
Okay. So all I've got. Everybody, Chinmay, Divya,
Yes, sir.
Gayatri, Geeta, Jovita,
Got it, sir.
Haripriya, Prabhu, Rajapriya, Priyanka,
Got, sir.
Saidivya, Shravani.
Got it, sir.
Okay. So we
Yes.
will be ending here. So we demonstrated today the general machine learning and how you can do the clustering. So two things we did it today. One is the clustering and next is the principal component analysis. Okay. So in the next class we will be going further with the Bayes theorem. Actually, I wanted to take the data set which I had given, but I couldn't. I did not do it. Some people are still to be still to come. So we will analyze the data in the next class. In the meantime, you can all practice this particular course. Okay, then any doubts here? Okay, if there are no doubts, I will be ending it here. So we'll meet on Friday around similar time hours, that is 7 by 7:30. Okay.
Okay, sir.
Okay, then see you. Good night.
Thank you, sir.
Thank
Good
you.
night.
Thank you. Good night.